We'd like to welcome everyone here. Will Hudson's our UGA entomologist that handles pasture insects for us. Appreciate y'all signing in this morning, and I'll turn it over to him and let him get started. We'd like for y'all to save questions if possible to the very end, and we can address those. Take it away, sir.
All right, let me make sure I can do this right. So I think if I push this to you, you should be able to see it. Can you see it?
Yes, we've got it.
Yep, I can see it.
All right, well, I put together a PowerPoint here for the top pasture insects that we deal with. It leaves plenty of time for questions if I don't answer something that's particularly on one of your minds. I don't go into white grubs here because they are kind of a special insect in our system. We can have problems, but we don't have very many solutions. So I'll be glad to talk about that when we get through to the end, if that's what you want to do. Okay, so now if I can get this to do what it's supposed to do. Here we go. We'll start off with the Bermuda grass stem maggot because this has lately become the #1 most pervasive pest for our Bermuda grass pastures and hayfields in the state from south to north. And it's done that in the space of just about 8 or 9 years from the time that we first found it in Georgia. In fact, it took it just 3 years from being found in Florida and Georgia and South Carolina to get all the way to Texas and Arkansas. So wherever Bermuda grass is grown, they have this fly. And that's pretty remarkable given the size of it. You can see there in the picture right next to a dime, it's not very big. It's pretty distinctive in appearance. It's got a yellow back end or abdomen with a kind of a charcoal gray. It looks dark in that picture because that one was in alcohol, but it's kind of a charcoal gray color in the abdomen. And there's usually anywhere from 2 to 6 black spots on the top of the abdomen, but that's pretty variable. We have learned a little bit about the biology of this. It's been difficult to study because we have yet to find a way to grow it in the lab. So we mostly do our studies out in the field and sort of indirect evidence that we can get in other ways. But we think that the fly lays its eggs on the terminal, top surface of the terminal leaf of a Bermuda grass tiller. And when that egg hatches, the maggot migrates down the leaf blade into the pseudostem right just outwards from the terminal node. They never go any further than that. You don't find them at any other node on the plant. No one's ever seen them lay their egg, but that's the only thing that makes sense to me. So that's what we're going with as a working hypothesis. They mash up the stem, the inside there above the node, and that's what kills the top 2 leaves of that tiller. It also stops the growth of that tiller. So Bermuda grass being Bermuda grass, of course, it'll just break out from a lower node and start a new tiller, a new leader, I guess you would call it. But that takes a little while, and it delays the maturity of the hay. And in certain circumstances, if the grass is tall enough when that terminal is killed, the surrounding stems will shade out those lower nodes and make them much slower to break and maybe even stop them from starting regrowth. And that really slows down the maturity of the hay and stalls out the growth. But the stems keep getting bigger, so you wind up with much more really thick stems and lower forage quality because of that. So their impact is more than just stopping the hay from growing. It has an impact on forage quality too. And I'll show you a little bit that we've learned fairly recently. If you haven't, most of you guys up in this part of the state probably haven't met Lisa Baxter. She is a former graduate student with Dennis Hancock and went out to Texas and got her PhD and came back, and she's a new specialist forage specialist down in Tifton, and she's done a lot of work with this fly in the last couple of years during her postdoc. So this is what the maggot looks like. You can see down here in the lower left, having been teased out of that stem, you wonder how you ever fit in the stem, and that's very common. It almost is like that. They prefer finer stem varieties when a larger stem would suit them better because they are pretty thick compared to the size of the stem. And this is what the adult fly looks like. Scott Carlson took this picture out in the field, which is pretty remarkable. But you can see the kind of the gray thorax up here and the golden yellow abdomen with the black spots on top. It's a pretty distinctive little fly. And the damage, again, just the top two leaves usually, although sometimes when they come out of the stem and drop to the ground to pupate, they will do some damage to the next lower leaf as well. But most of the time, if you grab these top two leaves and pull, they come right out, and you can see the end of that is all mashed up. That's pretty diagnostic for fly damage compared to some of the other things. But to me, the thing that tells you it's the Bermuda grass stem maggot and not something else is the fact that the damage is confined to these top two leaves. If it's frost, it'll get some of these others. There can be drought stress and some other nutritional type things that'll turn the leaves of the grass brown, but it's never limited to just those top two leaves. So that's really the distinctive symptom here. And this is what it looks like in a pretty badly damaged Bermuda grass patch. And you can see if this was in October or November, you might think a light frost had hit the tips there, but this is all fly damage. And that's distinct from armyworm damage, which sometimes gives kind of a brownish cast to the grass, but if you go and look, it's brown because there's nothing but stems left and the worms have chewed off all the green leaves, but the leaves are intact on this and only the top ones are killed. So the question of what to do about this came up immediately when we started having problems, and through trial and error and a few guesses, we wound up with a system that seems to work pretty well. They definitely prefer finer texture varieties. They hit those earlier and they do more damage to things like Alicia or Coastal or Russell than they do to Tift 85, which is probably the most common of the sort of coarser stem varieties that are grown. The management plan that we've settled on is that you check the grass before you harvest, and that's particularly true in June and July. If you're in the extreme South Georgia, it might happen earlier than that, but for most of us here in mid to North Georgia, the damage starts in July. So if when you go out to do your July cutting, you notice that there is damage, a lot of symptoms of presence of the fly, then you need to plan to treat to protect the next cutting of hay. And the best timing for that is usually about 10 to 14 days after you cut, not after you harvest, but after you mow the previous cutting. And that timing works because of what we have learned about the biology of the fly. The life cycle is about 3 to 4 weeks, but the last 10 days or so of that is spent in the pupal stage in the soil. And we know that if you mow the hay, those maggots that are pretty mature and ready or close to ready to pupate will just come out and go into the soil and pupate. So even though when you mow the hay, there's no new growth or no terminals that the fly might lay its eggs in, and the adult flies that are in the field will leave. They fly off to the edge or somewhere else. But those maggots drop into the soil and begin their pupation, and there are already pupae in the soil, so you'll have adult flies emerging right on through for the next 7 to 10 days. It doesn't matter if there are flies in the field if there's no new growth for them to lay their eggs on. So what we're suggesting is that somewhere around the 10-day mark is when the grass really gets going well, unless it's a really dry period. If you're irrigating, you might push it and get it to break out a little bit earlier than that, so it might be closer to 7 days than 10, but somewhere around 10 to 12 or 14 days after cutting turns out to be the ideal time to apply pyrethroid over the top. And that gets the flies that have emerged from the field from the soil in the field and those that have returned to the field when the grass starts to regrow. And our experience has been pretty good with this. If the grass has adequate moisture, one application has been adequate to stop the damage that these flies can do, almost completely, not entirely, but enough that the damage is not of any economic consequence. If you have a dry spell or the grass is growing slowly, you might need to make a second application about 10 days after the first, but it's almost pointless to spray the grass once it's up to 8 inches or so. 8 to 10 inches is about the time where you have to decide whether you want to harvest it as it is and start it over again, or try to make an application. Most of the time you're better off just cutting what you got and trying to reset the clock on that. So that's what we came up with for Middle Georgia. We're really looking at the July cutting. The single application has been very effective. And if the field next door is mowed, you know the flies are going to move. And that's a key thing. They are very, very mobile. And we've had invasions in our test plots. They're in Tifton. If you've ever been down there, the Forest Service has a little regional headquarters there right at the edge of where we grow our Bermuda grass test plots. And we had an incident a couple of years ago where we had a graduate student that was monitoring the flies every day, and he went out day after day and he was catching 2 or 3 or 4 flies in 10 sweeps. And he went out one day and he was catching close to 200 flies in 10 sweeps. And it's because they had mowed the grass under the pecan trees around that Forest Service headquarters. So you can build up big numbers of flies in relatively short grass and not really even notice it, particularly if you've got a place like that, or like we have on the Ponder Farm under our pecan trees, where you don't really care about the quality of the turf. It's mixed weeds and common Bermuda, and you're not really looking very close. And they can build up pretty big numbers in grass if you'll let it get up 4 or 5 inches tall before you cut it. So be aware that when the Bermuda grass that they are in is mowed, the adults will pick up and move, and they can fly a pretty good distance, and you can get enormous numbers invading in just a very short time. Okay, so let's look at the economic impact of this fly on our Bermuda grass, particularly our hay fields, which is where we're really concerned. In pastures, the cows just eat the flies right along, and you get a little bit of a kick of protein in the hay. But if we know that the yield might be reduced by 30 to 40%. We have had test plots where it was as high as 85% reduction in harvest of the fine stem, the Alicia. So this is what we're seeing overall across all of the cultivars that we looked at. The only one that didn't benefit from the treatments were Coast Cross 2, which is not all that commonly used. Most people go with the T85 because it's a little higher yielding typically, but you can see the finer stem, the Alicia, the Coastal, the Russell gets a pretty serious hit. And in this particular 2-year study, even the Tifton 85 was taking a pretty good hit from stem maggots. And this spray program involved 2 sprays because we were looking at it as a protocol. So it was sprayed at 10 days and again at 3 weeks. And this research was sponsored by the Georgia Beef Cattle Commission, which has been very generous in helping us do some research on this fly. You might be aware that federal granting agencies are not all that enthusiastic about relatively minor pests, and this usually follows in that category. So anyway, the more tolerant cultivars should be considered. But if you know anything about the horse hay market, you know that this Alicia and Coastal and Russell, that's what the people that pay big bucks for square bales to feed their horses, that's what they want. They want the finer stem varieties, not the coarser, what we would consider more cow feed type varieties. So we've got about 400,000 acres of Bermuda grass in Georgia. If you look at it, and if I remember Dennis's comments correctly, that's his estimate of hay acreage in the state. If you look at a yield of 4 tons per acre per year, and that depends on the variety and how you manage it, whether it's irrigated or not and all that stuff. And we go with a conservative 25% yield loss in those susceptible varieties, and a few other assumptions that usually work out pretty well. You're looking at a 1.6 million tons of Bermuda grass hay, which winds up with 400,000 tons of yield loss in a year. And at $100 a ton, that's $40 million lost in the state of Georgia. And this is the kind of number that our administration loves to see, particularly if we've got a solution, which in this particular case we do. So if you look at $15 per acre application cost, and that's mostly the labor and fuel for the tractor and all that, because the pyrethroids spray out at about $3 an acre at most. You're looking at, if you treated every acre, you'd be spending about $12 million on those last 2 harvests, the August and September harvest typically. And so that's $28 million that you would recover just from the treatments. And that's another one of those numbers that our administration really likes to see. And if you want to put it down to 25-acre hayfield, just so we get down to individual growers here, you're looking at, you might lose 25 tons of hay, which in many cases that 25 tons is going to be sitting in round bales around the edge of the field anyway. But for the high dollar hay, that's not going to be the case. And he's looking at losing about $2,500 on that 25-acre field. And for $750, he could recover $1,750 in income on that relatively small 25-acre hayfield. So we can now put numbers to this that will help us to get grant support, hopefully outside of just the local commodity commission, and do the rest of the studies that need to be done to really tackle this problem. So that's the stem maggot story, and there's some numbers there that you guys can use if you want when you're talking to your growers. I'd be happy to make all this available. This mostly comes, as I said, from Lisa Baxter's work down in Tifton. But if you think it'd be valuable, you're welcome to it. Are there any questions on the stem maggot before I move on? All right, let's do armyworms then. This is the worm part of the armyworm. You can see the variability in color can be pretty extreme. We have a couple of different varieties, I guess, or strains of armyworms that are around. They usually refer to them as the cotton or the corn strain. The corn strain is what usually gets in our grass. The moth itself is kind of a mottled brown, and once you get used to looking at them, you can identify them pretty easily by these marks on their wings and the whitish spot out towards the tip. They lay their eggs in a mass that they then cover with scales off of their body. And you can see I've teased the scales away in this picture so you can see the eggs in there. There may be 200 or 300 eggs in an egg mass. And the moths will lay eggs in the evenings for a period of about 2 weeks that the adults live. And they lay their eggs on almost anything over the grass. They would prefer not to lay their eggs in grass. If you've ever, those of you who may have done some work on golf courses or who are golfers, you may have seen the flags on a green that were covered with these egg masses, even though the food for those larvae is down on the ground in the grass. And the fact that they are so willing to put this up somewhere else, whether it's the plastic cover over the guy wire of a power pole or almost anything rather than put it in the grass, tells me that there's a lot of predation and parasitism that goes on down on the ground for these eggs. Because otherwise it would make no sense not to lay those eggs right where the larvae were going to start feeding. And we don't see that behavior as pronounced, at least in broadleaf crops like cotton and soybeans and peanuts and other things like that, where they usually lay their eggs right on the leaves of the plant. These moths don't overwinter anywhere in Georgia. They're mostly down in the lower part of the peninsula of Florida and they move north on weather fronts beginning in the spring. And there's a progression as they move into the state. We'll see them in South Georgia before we see them in Middle Georgia, before we see them in North Georgia. They are fall armyworms if you get further north. For us, they're really southern or summer armyworms. And pretty commonly, we begin to see problems in July. And by the middle of August, all the way up to the northern part of Georgia, we've got plenty of armyworms around. Some years are worse than others. It's hard to say what causes those cycles. Dry summers are sometimes worse. That's the observation. And in my observation, it's those dry springs that are the worst, because the major natural controls for these guys are diseases, fungal diseases primarily. And in dry weather, those fungal diseases don't get a foothold, and so you don't wind up losing very many armyworms along the course of this year. For whatever reason, we see really bad outbreak years some years, and not so bad in other years. And that's a curiosity from the entomological standpoint, but it's important when it comes to trying to make a decision of how to manage your pastures and hay fields, because when they attack really makes a difference in what you can expect and what the economic consequences are going to be for the rest of the year. So again, you look out at a field that's been attacked by armyworms and it looks kind of brown, but if you look closely, it's brown because the stems, actually in this case, this green is mostly weeds. They have eaten out almost all of the green leaves off of the stems of that Bermuda grass. And that's an important symptom to know that it's one of the caterpillars, and almost always for us it's going to be fall armyworm. The threshold for this, there are a number that you can find in the literature. Some of that literature is even from the University of Georgia. But the threshold varies. It says here with size and weather, and that's absolutely true. But for me, the threshold varies with the time of year. So if you're looking at armyworms in your hay field in September, that's a very different thing than seeing armyworms in your hay field in July. In the first place, your July yield is going to probably be the best you get all year, and the forage quality is much better. And the implication of not killing them in July for what happens in August and September is much, much more important than the implication for not killing them in September, when you may be able to just let them go. So there are a number of good treatments. Confirm is an IGR. It affects only Lepidoptera, only caterpillars. And that's good from the standpoint of other things that might be going on in your pasture. The pyrethroids are pretty good, although we're beginning to see at least suggestions that resistance might be developing here. And we've been hammering armyworms with nothing but pyrethroids for about 10 years now. Maybe more than that, actually more like 20 years, since Sevin changed the label and you couldn't spray it while the cows were feeding. So it's not a surprise that we would begin to see some indications of resistance there for the pyrethroid. Sevin is still legal, but because of grazing restrictions and the price, frankly, it has not, its price has not gone down to the same way that the pyrethroids have. The pyrethroids are probably preferred over Sevin by almost all of our growers. And then Dimlin is another IGR that is a pretty good, very good on caterpillars, stops development, but it's not specific to caterpillars, so it has some other impacts in the ecosystem. And of course, in the last few years, then the diamides have become the gold standard here. We're talking mostly about Prevathon or Coragen, and Besiege is a combination product that has both the active ingredient in Prevathon plus a pyrethroid added into it. And that might make it a pretty good choice if you've got armyworms and stem maggots at the same time. Other than that, I think the Prevathon just straight is every bit as, obviously that's going to kill your caterpillars pretty effectively. But it's an interesting marketing strategy that the company has, in that you can usually get Besiege at the same price as Prevathon, or perhaps even a little cheaper. It makes no, I'm obviously not an economist because it makes no sense at all to me, but that's big business. So the decision of what to treat with is one that is not always simple for growers to make. And a lot of it depends on how much time they have, if they're full-time farmers and are really paying attention, or if they're part-time farmers working somewhere else and don't really have the time to get out there and check on things all the time and keep quite as close tabs on what's happening in their pastures. Those people may make a different decision depending on those situations. So how early they show up is probably the biggest factor. If they're there in July, then you need to be aggressive in your treatments. And that's what justifies the high dollar Cadillac treatment. If they don't show up till September, you know what, you're probably only going to have to make one application anyway. And so $3 is a lot less than $15 that it's going to cost you for the diamide. The difference is if you have to come back more than once. So, and the other question is, how much hay do you have? And how much do you think you're going to need? And how much you think you're going to need may be the key here. If we have a good growing season in the summer, there's an awful lot of hay that goes unused on the side of the fields. It doesn't make any sense to spend any money to protect hay that you don't need. But most of our growers have a lot of trouble figuring out exactly what the market's going to be or what they're going to need, because you don't know what the weather's going to turn to the next time. So this how much hay do you have and need is really only important, it seems to me, on those last cuttings of the year and when you can decide to let it go or not. And how much you want to spend, this is another one of those questions. So you can apply pyrethroid for $15 an acre. If you apply the diamide, that's going to cost you more like $25 an acre or so, because the material itself is $15. So $15 an acre versus $25 an acre, that's a pretty easy decision on a one-shot deal. But as soon as you have to treat twice 15 is 30, not 25. So the diamides will last you probably 3 to 4 weeks, depending on conditions. The pyrethroid is going to last you 5 to 7 days. So this is where you have to decide what you think you're going to need and where you are in your growing cycle, how close you are to harvest. All of those things figure into it. But if you're going to have to treat more than twice, at twice it's a toss-up. At 3 times, it's clear you should have gone with the diamide. So that to me is the decision process that people need to undergo. Any questions on armyworms and that decision before we go on to fire ants? Hearing none, we'll go with fire ants. I get a lot of calls about fire ants in pastures and hay fields. The question of whether it's worth controlling them in a pasture is, in my mind, an open one. Some people just don't like to see the mounds out there. Some people are convinced that they will sting and even kill their newborn calves. It's much more clear cut in hay fields because those mounds get in the way of your haying equipment. They get in the bales themselves. There's a good reason to control fire ants in a hay field. Either way, whether you are in a hay field or a pasture, the question of how you approach it is going to be the same. And it's useful to think of treating not for individual ants, certainly not in their hundreds of thousands that would be in an individual mound, but rather thinking about treating the entire colony, because that's the unit that you have to deal with. Killing ants is a waste of time. You've got to kill a colony to really do yourself very much good. And a little bit about the biology will help you decide what has happened and what you need to do. Remember, the colony life starts when the mated queens go into the soil, either through a crack or a crevice, if it might be along a sidewalk or something like that, or just digging down into the ground. And they construct a cell in the earth and lay their eggs. And there might be 12 or 15 eggs. And she seals that cell up and doesn't emerge up to the surface again during the entire time that those workers are developing. And it takes almost a month generally to get those from egg till they become adult workers. So she's in the ground, not feeding, and feeding those developing larvae off of the resources in her body, the breakdown of the wing muscles, because she dropped her wings when she came back to Earth after mating, with fat bodies that are stored in her abdomen. She's really depleting her own personal supply of energy to get those first 12 or so workers through. Once they are adults, they break out of the cell and come to the surface to start to forage. And then she sits back and just lays eggs. And they feed her and they feed the developing brood. They take care of the developing brood. They construct the mound, the nest for the colony. And remember that dirt up on top is just what came out of the constructed tunnels and cells down under the earth. So it's very much the tip of the iceberg. And it takes about 6 months from the time that queen hits the ground to the time that the colony has matured to the point where they can produce new queens to go on and found new colonies. And that 6 months, give or take, is an important time frame to remember, because that's what underpins the whole strategy of the two-step treatment. So just a few facts to keep in mind. There's the fire ant queen herself can live for 7 years, and that's why killing all those workers is not going to kill the colony. She just sits down in the ground. She's still got some workers around her that are taking care of the brood and feeding her, and she's not going to be worried by the loss of 100,000 workers up on the surface. Those individual workers can live 60 to 90 days, although in the field it's probably more like 3 to 4 weeks. You may have 400,000 workers in a mature colony of fire ants. And that's why you can go out there and spray something on the surface of the soil and kill fire ant workers in droves, and you think you've killed a gazillion of them. Actually, you probably killed 50,000, and that's not but about 12% of the colony. And that's what makes that such a waste of time. Because that queen can lay 1,000 eggs in a day if she's in her prime. It doesn't take very long to replace that 40 or 50,000 workers that you killed. So the swarm starts, you see adults, males and females come out, they go up into the air and mate, fall back down, and where they fall is completely determined by which way the wind's blowing when they go up. Their flight into the air is strictly to get them off the ground and together so they can mate in the air, and it's not directed. They're not up there looking for a good spot to land. They fall back to the ground wherever they fall. And the major mortality factor for those newly mated queens is predation by other fire ants. Because once they leave the colony, if they come back, they're just food. A little bit more about it. The queen is much larger than the workers. You can have very small workers. The smallest ones that they produce are those first 12 or so. They get bigger with time. They have some soldiers or more aggressive forms. And then the winged adults, male and female, that fly out. What you see when you kick the top of a mound and the ants are scurrying around carrying little white things is usually not eggs. The eggs are very small. It's usually the larvae or the pupae. And those workers will move those up and down in the mound to take advantage of the cooling or warming effect of this mound. And that's really the purpose of the mound, is climate control. If you go out there after a cool night and the sun starts to hit the top of the mound, if you kick the top off, you'll find all the workers up there with all of the brood, because they moved them up there where it's warm, so they'll develop faster. If you go out there in really hot, dry weather, you could kick the top off that mound and dig a foot down and you won't find any, because they move them down into the soil to a place that's more comfortable for them and where the humidity is a little higher. So again, the brood will develop most efficiently. And just a schematic here, they do not forage in really hot weather, over 95 degrees or so. So if you put a bait out in the middle of the day in August, there's not many fire ants to find it. They don't like cool weather. They don't forage very much, although they will come out on a sunny day if it's in the 60s. They really like to be up in the 70s to be foraging very actively. So that's why in the heat of the summer, you see them foraging mostly at night and dusk and dawn, not so much in the middle of the day. But this time of year, they're active all day long. And again, they're moving stuff up and down in the mound. They'll have the brood up at the top if it's cool outside and the sun's hitting it, and they'll move it as far as 3 or 4 feet down in the soil, looking for the right humidity and temperature when the temperature on the surface is too hot and dry. Okay. So all of that is what is behind this two-step program. You put out baits twice a year. And after you've treated with the baits, come back a week or so later and you can do mound treatments for established colonies. And when you're first starting, this is this program that we recommend for anything over about an acre, which is all of our hayfields and pastures. Your broadcast or contact treatments, that's not individual mound treatments, can knock down a lot of surface activity from workers. It's sometimes the only thing you can do if you have a small suburban yard. You know, you're down to, in many cases, less than a quarter acre or a half acre, including the house. So that's not a whole lot of area. It's the most expensive thing you can do other than treat individual mounds with a bait. But sometimes it's what makes sense. Okay. The baits are cheap. For 2 applications, you should be able to get away with $20 to $30 an acre. It takes some time for them to control, and that's because the workers don't actually eat the bait. They carry it back to the mound, they feed it to the developing brood and to the queen, and so the effects of those baits are not on the active adult workers, they're on the brood and on the queen. So they either kill or sterilize the queen, they either kill or stop the development of the brood, but anything that's pupated already in that mound is not going to be affected by that. And the adult workers are not going to be affected because they don't eat it. And that's why it takes a little while for you to get to realize the full control. You got to wait for those workers to die of attrition. And they're not going to be replaced except by whatever was already in the pupal stage. But you're going to have to wait till all of them die and aren't being replaced by the queen that's been killed or sterilized. So you have to build in that 3 to 8 weeks. 8 weeks is the extreme end if you have a low rate application of one of the IGRs. 3 to 4 weeks is more typical, and you really begin to see a significant reduction in activity after just a couple of weeks. And it might be at that point where if you're talking about a home yard or a commercial lawn or park, it would be wise to go in with a contact, a broadcast spray that would kill the workers that are still active and speed up that process. We have a lot of pretty good baits. I think the hydromethanol Amdro and Amdro Pro are probably the most common. They're certainly the oldest, but these others all work equally well. They all recommend an application of about 1 pound to 1.5 pounds per acre, which is not very much. And for most people who are expecting to treat large acres of pasture or a hayfield or a park or something like that, it makes sense to invest in a spreader that you can put on the back of a 4-wheeler or a pickup truck that you can calibrate down to that 1.5 pounds to the acre amount of application. And Herd is one company that makes a number of these that are designed specifically for this. Syngenta used to have a program where they would help subsidize the price of that spreader if you bought their products, but I think that program has expired. But you can see there are a lot of names, and this is by no means an exhaustive list. Again, Amdro and Amdro Pro are probably the most common. Amdro, I think they call it Amdro Plus, has Extinguish in it as well. Extinguish is got the methoprene insect growth regulator in there for a little added kick. In practice, I don't think there's a whole lot of difference between those two. For homeowners, they have come up with a formulation of Amdro that doesn't apply at 1.5 pounds to the acre. It applies at 2 pounds per 1,000 square feet. And what they did was just take the regular Amdro and then mix it with granules that didn't have any hydromethanol on them, so that they put a bunch of blanks, in other words, just to increase the volume to make it easier for people with push spreaders to calibrate, because no one can calibrate a push spreader down that low and think they're doing anything. And so inevitably, a homeowner trying to put out 1.5 pounds to the acre is probably putting out between 5 and 10 pounds to the acre, which isn't a problem, except that it costs, 5 or 6 times as much. Commonly used contact insecticides. We don't use these in pastures and hayfields, or at least we shouldn't be. Hopefully we are not. I would point out that the fipronil here is by far the Cadillac treatment. In a turf situation, that's a $250 application, but it will get rid of your fire ants for a solid year. You can get pyrethroids, including permethrin, which is the oldest of the pyrethroids, the first one that came out, and it'll promise you 12 months of fire ant control in your yard with a single application of those granules. And that's a lie. It will not give you that. It will probably give you a week or two. Bifenthrin, the best of those pyrethroids, will give you maybe 3 weeks or so of no ants. But it's definitely not going to give you a year. That's just not true. You'd have to do it 2 weeks before they went dormant for the winter to even get 2 months out of it, much less 12. Okay. I would say that natural control has turned out to be the most effective. We have released some biocontrol agents. The little decapitating fly, which has got a lot of press. There's also a protozoan, Tillahania, which has been released and is established in a lot of the fire ant colonies in our state and across the Southeast. All those really do is weaken the colonies and slow the rate of spread and the rate of reinfestation. Competition from other ants can eliminate fire ants from an area. We have very, very few fire ants in the Ponder Farm pecan orchard down in Tifton anymore, and that's good. The reason we don't is because Argentine ants have displaced them, and that's not good. Argentine ants have become probably the main pest ant that our pest control operators all across the state deal with in homes and around homes. They are very aggressive. They don't sting. But from the farm standpoint, in a pecan orchard, the problem with having ants in the orchard is that they tend the aphids and protect them from natural enemies, and you get much worse aphid problems in those orchards. And Argentine ants are just as inclined to do that as fire ants. So it's good that we don't have fire ants. They don't sting us, but we still got to control Argentine ants to get the maximum natural control on our aphids. And the latest thing that's coming in is called the tawny crazy ant. Dan Suter's done a fair amount of work with this thing. It is an interesting ant as an entomologist. When you watch it, it's called a crazy ant because it is very, very active and manic in its movements. The first time I ever ran into him, I was standing and I felt something on my leg, and I looked down and there were probably 100 ants running up and down my leg. They wouldn't sting, they didn't sting, but they seemed to have no particular purpose in mind except to run up and down. So it's a completely manic behavior. They reproduce in enormous numbers, and again, they overwhelm the fire ants. And what you see here is dead ants from a colony, whereas 400,000 workers is a big colony of fire ants. You can have 1 million workers in these guys, and they ants die, and they haul them out and lay them out in windrows outside of the colony. So it's an interesting thing. You think, well, gee, something's killing all those ants. Yeah, the same thing's going to kill us all. Time and nature is going to kill everything eventually. So these are just old ants that died. It's not a good sign, not bad, but it's not good. It's not really of any help. So this crazy ant is going to be the next thing that helps to rid our state of fire ants, but I'm not sure that we're likely to be any better off. Okay, that's all I've got. Ricky, if we want to ask questions, I'll be glad to answer anything that you've got, whatever suits you.
Do we have any questions for Will?
When is the best time to put the bait out for the fire ants?
It depends a little bit on where you are. You have to wait till they get active in the springtime. For most of Middle and South Georgia, just as a rule of thumb, the timing is probably going to be late April and September or October. For the further north you go, the further into the year you get before they become active, and the more likely that cool weather is going to slow them down before they really reach that 6-month development stage where you start to have mounds pop back up again. So a lot of times a single application is enough in North Georgia, and that's probably going to, in most years, fall in either May or June. We've also seen that if you're treating large areas, and most of the work here was done in turf, like in corporate grounds or parks or something like that, if you apply the baits twice a year for a couple of seasons, you knock the number of colonies down so far that it's only around the edges that you're beginning to be reinvaded. And at that point, you can start to apply the bait really just around the edges. So you're treating a donut rather than the entire area. And obviously, the bigger and more square the field that you're treating, the more that saves you. So for most of us up here, particularly if you get north of Atlanta, a single application is probably going to be enough in most years once you've got the population knocked back pretty good.
Thank you.
Will, what about fire ant control in like a horse pasture? What would be ideal for that? Is extinguished the way to go, or?
Horse people are peculiar, it seems to me. You have more options in a horse pasture, particularly in Georgia, because you're not going to eat the horses. So it's only for food animals that your options are restricted in terms of which baits are available to you. In a cattle pasture, a lot of those names that were on that list are not labeled for food animal pastures. And the reason for that is that the companies would have had to do feed-through studies to get it legal. If it's companion animals only in the pasture, then you can use a lot of those other ones too. But other than that, the approach is the same.
Any more questions for Will? Going once, going twice, sold.
All right, you know how to get in touch with me, so anytime I'll be glad to talk to you or come up and visit.
We appreciate it, Will. Thank you so much.
Mm-hmm.
Everybody have a great day.